Double angle identities. So I'll work a couple of example problems. Typically, you'll be given information, like something like this. Cosine of an angle is given, location of the angle is given, and then I want to find, the sine or cosine of twice that angle. Again, you'll be given the identities, so you don't need to worry about memorizing those. But the first step is always going to be to draw the angle. And so angle A in the fourth quadrant. So I'm imagining angle A like this. The cosine of A is 3 over 4. So adjacent 3, hypotenuse 4. And I need to find this missing side. And so I'm going to say 3 squared plus y squared equals 4 squared. Y squared equals 16 minus 9. So y squared equals 7. Y equals plus or minus the square root of 7. And so this missing side over here is going to be minus the square root of 7. And this is my angle A, if I want to think of it that way. So for number 1, sine of 2A, my identity is I take 2, I multiply that times the sine of A, and then I multiply that times the cosine of A. The sine of A, opposite negative root 7 over hypotenuse 4, times the cosine of A, adjacent 3 over hypotenuse 4. And then I simplify that, and I get negative 6 root 7 over 16. And that's my final answer. Similarly, for the cosine of 2A, the identity for cosine is cosine squared angle minus sine squared angle. So here, the cosine of A is 3 over 4 squared minus the sine of A is negative root 7 over 4 squared. And so maybe a couple steps to simplify. 3 over 4 to the second power is 9 over 16. Negative root 7 over 4 to the second power will be positive 7 over 16. 9 over 16 minus 7 over 16 is 2/16, which I can reduce if I want to 1 over 8. So that's how I'm working those problems. Given information, draw the picture, and then use the identities appropriately. But again, you don't need to memorize those.